Hello again, welcome back. Today's video we're going over Phelan. Phelan is a new retired machine from Hack the Box. The machine is rated as difficult, as you can see from here. In this machine, we're going to be learning how to exploit Java deserialization vulnerability, which is recent CVE, and we're going to be exploiting another CVE to do the privilege escalation. So let's just jump in. So this is nmap scan. Nmap scan reveal we have two open ports. One on, as you can see, 8080 and one on 22. So let's browse now to the port 8080 and see what do we have. It's clear that it's running Apache Tomcat 9027, and there is a title, virus bucket. Let's see what virus bucket is. Connect. So we provide a malware analysis and testing platform right from the comfort of your browser. The website and service will be open to public soon. Okay, safe and secure. Read more. Nothing. Home. Virus bucket. Service. So if you click on service, you see you can just type in your email and upload a sample to analyze. You can upload any file. So which makes me think that there is file upload vulnerability. But it will turn out that it is not the case. So how I did this challenge, I just fired Burp Suite. In Burp Suite, I tried different samples of uploads in order to trigger some kind of error. So from the error, we will be able to see the upload path. If we are able to find the upload path, we will be able to navigate to the upload path and trigger some kind of reversal. So Burp Suite is now running. So here let's experience with some sample files. Okay. So the first thing what I would do first, I would create a PHP file that contains a simple PHP payload. So sudo PHP or nano PHP sample. So here I would say PHP echo system. Get cmd. All right. Nope, not the case. I think we have to put here like that. Now we close the parentheses. So analyze. So here we can go to desktop. Hack the box, failing. PHP sample to fill. So PHP, and here echo system get cmd, and we finish this. So now we upload this file and we turn the interceptor to be on, forward. Okay, choose the file, test, upload successful, right? The report will be sent via email analyze. So as you can see, the file name is here and it's this contents. Now let's intercept the response and try to find out if the upload path will be revealed. So intercept the response, forward, invalid file name, forward. So it seems like we have to modify on the file name. Let's sudo md php, rename it to sample. Upload one more time. Sample. Intercept. And now the file has been uploaded successfully, but we cannot find out the upload path. So far, we can't do anything with just what we have done, right? Because we don't know the upload path, so we can't trigger any shell we upload. So I'm gonna just forward and try some new file or try something that will trigger an error, right? I want to trigger an error. The error is supposed to reveal some path, right? Since this is Apache Tomcat, and sometimes when you test Apache Tomcats, if there was an error as a result of an action you did, right, there will be a display of there will be display or debug about the information. So that's what I'm looking for. Let's do the same, but in this case, we're gonna empty the file, make it empty. If the file is empty, right, it means that there is nothing to analyze. So here the service is expecting you to upload a file with some contents, right, in order to analyze it. If you upload a sample file with no contents, it means that the service there will be something wrong in the file from the perspective of the service. So if we upload here sample again and analyze the same one but without content, analyze. So see, it's empty. Intercept the response, forward. And again, file uploaded successfully. All right. Okay. How about so it doesn't trigger an error. So we have to, if we rename this file to some empty name, right? Like this. So let's see here. Upload. Check. Let me reverse it. I think we can just make it empty or replay with the name when we upload it. This way is not gonna work. So upload sample. Now, oh, this one needs to be on. So here, let's do it like this. Remove the sample and make everything empty. Let's see if an error will be triggered. intercept the response, and we have an error. So it's saying here, file not found, exception, opt samples uploads. This is your upload directory, guys. So that's how we will upload the reversal. But as you can see, this is Java application. So we have to find out how we can upload reversal using Java. So opt samples upload. Let's store this somewhere and leave this like that. All right, let's get back to the Nmap scan. So Apache Tomcat 9 025, right? 027. 0.27 exploit. Seems like some people were looking this up. Vulnerabilities in Apache Tomcat 9027. Apache Tomcat RCE by deserialization. So when you read deserialization, it means that there is something Java is involved, right? So, and the scenario here applies on this case. So this seems to be the post we're looking for. CVE-2020 9484. A few days ago, a new remote code execution vulnerability was disclosed for Apache Tomcat. Affected versions are, as you can see, 9x all the way till 9035, which applies to the version we have in hand. So let's see how we exploit this. There are a number of prerequisites for this vulnerability to be exploitable. The persistent manager is enabled and it is using file store. So if you know how to work on Apache Tomcat, you would know that it requires the persistent manager is, when you save a file or when you request a session, right? The session will be looked up in the memory. If persistent manager is enabled, it will be looked up in the disk as well. And this explanation here, first some more about the persistent manager, you can read this, why the persistent manager needs to be enabled. Because in the session, we will be setting the session to a path in the disk. So if it is not enabled, it will only look for the path in the memory. We don't want this. We want it to look in the file. We want it to look the file in the disk as well. The attacker is able to upload a file with arbitrary content, has control over the file name, and knows the location where it is uploaded. Requirement 2 is already satisfied. The requirement seems to be satisfied, assumingly. We're going to assume this. There are gadgets in the class path that can be used for a Java deserialization attack. Okay, configuration. The default Tomcat will run the standard manager enabled. An administrator can configure to use the persistent manager instead by modifying conf context XML. When there is no manager tag written in the context, the standard manager will be used. Now this is the exploit. When Tomcat receives a HTTP request with GSessionID cookie, it will ask the manager to check if this session already exists, because the attacker can control the value of the session ID sent in the request. What would happen if we put something like JSessionID temp 12345? Okay, Tom requests the manager to check if a session with session ID exists. So here, if the persistent manager is enabled, when we modify on this, right, it will look in the memory, and if it doesn't find, it will look in the disk. So since we have control over the uploaded files, we can just upload a file on the disk and let the session manager find it. The persistent manager find it. It will first check if it has that session in memory. It doesn't, but the currently running manager is a persistent manager, so it will also check if it has the session on disk. It will check at location, directory, session ID, session. So we're going to play with this, which evaluates to session, and this is the path, right? This is your path. This is the upload path, right? will be playing with this one. We have control over this. Dot session and slash session. If the file exists, it will deserialize it and parse the session information from it. But we have first to figure out how to upload a payload that will be deserialized. So for this, we're going to be using a deserializer or serializer, sorry, payload generator for Java serialization and deserialization. So proof of concept tool for generating payloads that exploit unsafe Java object deserialization. And this, since the Apache Tomcat version we currently have in our case is vulnerable to Java deserialization as proved by this post, we're going to be using this tool here. So let's clone this tool. Clear or keep it. Okay. Ls sudo git clone. Okay, let's now generate the payload. Now, if you read the post here, it has instruction on how to generate the payload, right? So download. All right. So let's see now the name of the file, CVE serial. Okay, this is the file. So the command will look like this. So now the command is complete. Okay, the payload has been generated, ls, and this is your payload. Just we're gonna move it to the felon directory. cd back, cd back. Oh, okay, so we have the payload now. Let's upload the payload, guys, and then trigger the payload by intercepting the JS session cookie. So intercept the request one more time. So before we upload the payload, we have just to see what should be the content of the shell.sh that will be retrieved when triggering the payload after the upload process is finished. So let's create now the content of the shell.sh. Sudo shell.sh. So in here we can just put some reverse shell. Right. So for me, I choose Python reverse shell. Of course, change the port and the IP address. 555. Hit config. This is the content of the shell. sh is ready. Now let's upload the file. Sample payload session. Intercept is ready. Analyze. Let's see. So this is the content of the payload. Now this is the JS session ID, right? Now let's first launch the Python web server. And on the left, Okay, the process is like this. We upload the payload and then we trigger it. So first, upload the payload. Make sure the upload process is successful. Intercept, forward, successful, fine. Now let's trigger the payload. But nothing has been retrieved from my machine. Oh, we have triggered, yes, okay. So now we trigger the payload. So let's pretend that we are uploading a file or analyzing a new file, like sample. And here we will just change this. Let's get back to the exploit. So we're gonna take this, starting from here. All right, the upload path is opt samples and uploads. The payload name is payload. Do not put .session, right? Because it's going to be appended automatically. So let's navigate and see if we get a hit. And we get a hit here, so it has been downloaded. Now I should receive the reversal here on the right. Okay, but as you can see, if we get back here, oh, yes, if you remember, the first payload was to download the payload from my machine and store the local file. We need to create another payload to trigger this a payload, right? So we will have to get back here and create a new serialized payload. So let's see okay, we are here. So let's see the last command we have just used. Okay, so that we have to write from scratch. So sudo java -jar yo serial yo wso. Okay, and then commands actions. So here we will execute the payload we have just uploaded to the server. Bash temp shell sh. Store this in payload.session. Okay, and we upload it now. So when we upload this payload.session, when it is triggered, it will execute bash /temp /shell.sh. And we should receive the reversal. So back sample analyze. So we can change this name so we don't get the old payload replaced. So put this as something like payload exploit and forward. Let's see now. Okay, and we get the reversal back. So the new shell that I created has worked. So I replaced only the content of the shell from Python to one-liner bash. So now what we're gonna do, let's see here, paste. Oh, we have stable shell, all right. So now we are Tomcat, and the GIT Tomcat and the group is Tomcat. Now it's time for the privilege escalation. For this machine, the privilege escalation will revolve around playing with Dockers. And the Dockers on this machine are listening on a local port that you cannot access from outside. So if you view the active connections with SS-LTA, you'll see that the local machine is listening on port 4505 and 4506, which are known for Dockers. Now, the software running the Dockers, in this case, it's SaltStack. If you go to Google and Google SaltStack, okay, I think it's time we turn off the Purp suite and revert the browser to the original settings. Settings, no proxy, all right. Salt, as you can, SaltStack Enterprise and SaltStack SecOps are now part of VMware. Commercial are now part of VMware. All right, there are more. Oh, so they are integrated with VMware now. Salt is Python-based open source software for event-driven IT automation, remote task execution, and configuration management. So it's used for IT operations, specifically configuration management, and also for developers. Now, if you get back, you see we have the Docker is listening on 4506, 4505. If you Google these ports, port 4505, as you can see, it's used by SaltStack. On the documentation, you can see this port 4505, port 4506. So means that we have Dockers installed. Git config. Let's see the Docker interface. So this is the Docker interface, Docker 0, and this is the IP, right? So we have to access these ports somehow from outside. But how do we know that the SaltStack is vulnerable? So basically, if you Google SaltStack CVE, let's see, SaltStack list of vulnerabilities. So the more recent ones are, seems like they are not here. Let's get back. So this one is nope. So we have to know the version of the current SaltStack, right? Let's go up. If you write salt stack vulnerabilities, Let's check out this one. So exploit salt stack vulnerability CVE-2020, 11651 and 11652. So the bottom line is saying two high severity vulnerabilities in salt stack 2020 and an authentication bypass vulnerability and 11652 a direct reversal vulnerability. These can be exploited by remote unauthenticated attackers and all versions of salt stack sold before 2019 to 4. Alright. The first one allows remote user access, and the second one permits arbitrary directory access. So most likely we're going to be sticking with the first one. You can take a look at Salt's architecture. Understand the vulnerability. Salt has a master-slave model, where the master is called the Salt master, and the slaves are the Salt minions. The Salt master is used to send commands and configurations to Salt minions. A single master can manage multiple minions. So most likely we're going to be using these concepts to get Docker to have root access. So in CVE-2020 1651, the salt master process clear functions doesn't validate method calls properly. And this is the code for patching the vulnerability. To fix the CVE, SaltStack has defined exposed methods that the user can specify in the clear text messages. This is done through a new function called get method. So the get method here, this is the one. So we put this in the container code and it should work. Okay, so this is the patch. We don't want to work with the patch right now. Let's find out an exploit. So it's a CVE 2020 11651. Seems like we have a couple of exploits. Let's check this out. Usage. So this is on Debian 10 against Debian 10 instance needs not cut to receive and send a shell and pip3 install salt forever. So master, and this is the payload. And once we execute this, it should send the reversal right to our machine. Great. Let's git clone this. Let's sudo git clone. ls cd cve. All right. So we have to transfer this now to the machine. Okay. Now here, ls case cd temp or cd dev shm ls nothing wget http 8000 slash, let's rename this, right? It's easier. CVE to, or let me copy it. Okay, leave it. I changed my mind. Let's take this. All right. -o dev shm salt stack exploit.py. Run the Python server. Execute here. Okay, the build has been downloaded. Now let's fire up listener, view, split, and c.lvp 4546. Now we execute. So let's see how this works. So basically, we define the master IP and we define the connection to where it's going to be dropping the root access. So salt stack exploit.py. Here we're supposed to supply the IP address of the master. So it is the IP address of the local of the machine, which is 10.10.10.205 master. And lastly, the net cut to my machine 10.10.14.5. Okay, the port is 456-E game dash finished right. Yes, but here we have to put double quotes. Let's see if this can work. Permission denied, sage mode plus X, salt, stack, exploited py. No such file. Oh, it has been deleted. Let's try a temp directory then. Okay. import salt, no model named salt. Oh, so we have to install salt. Okay, so Python pip restore salt. Seems like we have to need administrator privilege in order to download the salt module, and we can't, so the exploit will not work. Let's search for something else. Let's see this one. Okay, git clone it. CVE, USC, exploit.py. The usage is, so we run the exploit, Python 3, exploit.py / master, and the IP address. But here it's going to be the IP address of / master. Here I can execute the command. Exploit.py / master, and we don't need to specify this IP. It's going to be the local machine -- execute. Okay, seems fine. So here the command we will be executing when the exploit works will be the same reverse shell we used earlier, the bash reverse shell. So it will give us netcat shell. So let's download the exploit. We get HTTP exploit UI -o. It's running on port 4505 4506 locally. So we will have to establish some kind of forward from our machine to the target host. So for this to happen, we will have to use Chisel. So on my local box, I'm going to run Chisel as a server. Listen on any port you want, -p, let's say 1990 -reverse. No such file or directory. Chisel server -p 1990 -reverse. Okay, now we need to transfer this to the remote host. So we'll have to download this locally, manually. So Chisel, come on, this guy, what's this one? Chisel, GitHub. So to put this on the local on the remote target, we will have to download it first on our machine. We did that, but we have to clone the directory in order to download it with wget on the remote target. So here's sudo home. So okay, let's see here. Int 64 to downloads. CD chisel. Okay, so the chisel to chisel, whatever, v2 v chisel. And move that to home. No such file or directory. Okay. So now we can download this from my machine. So cd to home, downloads desktop. So execute /c, takes as a home. Okay, and here make it run in single quote. So the exploit successfully run, and we should receive the reverse shell on this instance here. Let's see, we haven't received anything, so we will have to modify on this some way. So here, as you can see, there is double quotes. Let's make double quotes here and single quote like that. Double quotes. Yes, now it's supposed to work. No. Single quotes. We have two single quotes. That's right. Two double quotes. Oh, look at this. So this one is okay. This one is not okay. Like that. Oh, so as you can see, it worked now. Now you are the root user, but you are actually the root user, but not the root user. Technically not the root user, because this is running inside a container. If you run lc-la, as you can see, this is the directory of the container. As you can see, root at something, which is the container. So you will have now to create a new container, all right, and dump the content of the root directory. Let's see what the sudo file contains. Sudo txt add salt stack support to auto spawn sandbox dockers, integrate changes to Tomcat and make the service run open to public. Let's try to see it root. We are able to see it root cat ls sudo.txt cat sudo.txt. All right, let me check the content of the var directory. var. More information about dockers and how they're running are found in the var and run. So cd run ls. So we have Docker sockets. And Docker socket, it is bad to use Docker sockets when you want to create a new Dockers. If you type ls-la, so we have docker.sock, which is socket for Docker, which means that makes me think that I need to check the bash history file, right? Docker.sock, by the way, it's like Unix socket, right? That Docker daemon is listening to, and it's the main entry point for Docker API. So it's not a good practice to use that to mount the socket inside a Docker. So this is mounted inside a Docker, or it is used to actually it is mounted inside this Docker, which is not a good practice. So it makes me think that in order to use the Dockers to dump the root directory, we will have to check the bash history file. So cat or cd back ls cd home. And as expected, check this out. curl-s Unix socket var run docker.sock HTTP localhost images JSON. So socket or Docker socket, which is the Unix socket, it is used to mount the socket inside the Docker containers. Now with this here, it's saying that the Docker socket, it is used to create Docker images, which means we can do the same. We can create a new Docker image to mount the root file system. So how I do that, we just follow the same command here, curl -s Unix socket var run docker socket. Okay, and can then create a new container. So it's going to be HTTP localhost containers JSON. So here, see the image ID. Where is the image? This is the image, right? So now we'll create a new Docker container. So I just copy pasted the next command here, right, to my local machine, and I modified on the source to be root, since we are mounting the root file system, and modified on the image, put the image ID you have just received from here. And after that, let's check on the rest of the parameters, root. Okay, the target is right, the source is right. Now here, instead of this, I'm gonna just type host slash container. It will be the target where you will mount the root file system. So say, I don't know, host root, yeah, host root container.json. Now take this, the first one, and run it. Paste. So the first command has been executed successfully. Now we have to run the next one. Let's check this out. Now let's throw that JSON data at the Docker engine and see what happens. Response from daemon, and then we start the containers. All right. So the next command is to run or start the containers here. Let's take this one. And work on it. So curl -expose-h, you have to put -h here, specify the content type, content type, application/JSON, yeah, dash Unix socket, var docker socket dash, so here, oh, okay. So here let's put -d to start our container that we have created. Cat container JSON. And here remove F9CA. Okay, now once we run this, we should get a response code similar to this one. Similar to this. Let's check it out. Take this one. Message page not found. Okay, one more time. Okay, so it worked. This is the ID. What's next? Response from daemon, that's the response we got. Now start your containers. Okay, let's take the command onto my local machine and to the third line. All right, so curl-expose-Unix socket var. And here we need to replace this one. Let's check out the response. Depending on the response we have got, we'll modify on this. So the first is saying 21A0, right? Now, if you get back to the page, why the first four characters? As you can see here, the exploitation is saying the response they got F9CA as the first four characters of the ID. And that's what they used when they started the container. So in our case, 21A0, 21A0. Yeah, start it. All right, let's see what's next. Now we use socket, right, to connect. So So the remote target doesn't have SOCAT, which is very weird. That's why we couldn't perform the last step. So I'm going to try to transform the SOCAT from my local machine to the remote target in the hopes that it's going to work. So sudo cp user bin SOCAT. So SOCAT doesn't exist, or it's not installed on the remote target, and I can't install it. So it seems like I'm going to need to retrieve it from my local machine, which I hope it will work. User bin to so SOCAT is here. Launch the Python server. Retrieve the SOCAT. Get 10, 10, 14, 5. SOCAT -o, or leave it like that. I think there might be some issues with the SOCAT. That's why I couldn't retrieve any results by running this command. But this is the last command that he would run. And after that, we're supposed to get the root file system mounted and finish this challenge. So we're going to stop here. I'm going to leave this to you. There are some problems with the SOCAT. And, so basically, I hope this was helpful. And please put down in the comments your feedback about how you managed to deal with SOCAT. All right. Thank you for watching.